Section 4.1 on absolute max and mins, page 2. So for example 2, we're only asked to find the critical numbers of the given function. So we previously determined that a critical number is when the derivative is equal to 0 or does not exist. Therefore, we need to start by taking the derivative of this function. So all I've done is copied the function over, but it caught my eye that I'm going to need a product rule derivative where I think of f as the x squared portion of the question and g as the x minus 4 quantity to the 4/5 power. So using f prime times g plus, g prime times f, I'm going to take the derivative of the f function and copy g as is. I'm going to take the derivative of g by copying the 4/5 out front, subtracting 5 over 5 to get negative 1/5 exponent. The inside stays as is, and when I take the derivative of the inside and get 1, you don't even notice it, and then write f as is. So the left portion really has no cleanup needed, but the right portion, I've got a 4 and an x squared that will stay in the numerator, but the binomial will come down to the denominator with the 5 so that I have a positive exponent. Now, I need to set that derivative equal to 0 or figure out when it does not exist, but I need that to be a single fraction to do that. So since I have a denominator on the right side and only 1 on the left side, I'm going to multiply by that denominator over itself. So it's really like I'm multiplying by a giant 1. So here is my 1, so to speak. So I can multiply the 2x and the 5 to get a 10x. And because I have the same base, the same binomial to the 4/5 and the 1/5, I can add those to get 5/5, which is just 1. So really, I don't have an exponent, and I can distribute the 10 to get my 10x squared and my minus 40. And now that I have this denominator, I can go ahead and add the other numerator. I should have caught that there were like terms before I moved on, but I didn't, but I catch it later on. So first I want to find out when does the derivative equal 0. That would be when the numerator equals 0. So I took just this numerator and set it equal to 0. That's when I noticed I had a 10x squared, a positive 4x squared to give me 14x squared. Because I have the variable showing up twice, I'm going to go ahead and start by factoring a GCF out, a greatest common factor. And because it's x squared, a second degree polynomial, I should get 2 answers. When I decided that between 14 and 40, the largest numeric value I could factor out is a 2, and between x squared and x, the largest variable I could factor out is an x, I essentially divided every term by 2x, leaving me with 7x minus 20 in the parentheses. And then using the 0 factor property, I set each factor equal to 0 and solved. So if you divide both sides by 2, I'm going to get x is 0. And here I would have had to add the 20 to the other side, divide by the 7, and I've got my 2 answers. The derivative does not exist when the denominator is equal to 0. So I took this denominator and set it equal to 0. Now, I went through all the algebra steps. A lot of you can just see, hey, if this inside is 0, then my variable would be 0. But I went ahead and said, in case that's not the option that you see, I'm going to write divide both sides by 5, but 0 divided by 5 is still 0. Because I have a fractional exponent, I'm going to take both sides to the reciprocal of that fractional exponent. 0 to the 5th is still 0, but my binomial to the 5th that was originally to the 1/5 is now to the 5 over 5 or the 1 power, so I technically have no exponent. Then I can add the 0 over. So there are 3 critical number values for this particular problem. Here's where that comes into play. We're asked to find the absolute max and min. So long as we have a continuous function on our closed interval, then we'll begin by finding the critical number, something we just practiced. Keep in mind we need to discard any critical number that is not in our prescribed interval. Then we will evaluate the function's critical numbers and those endpoints in the original function. The largest output is obviously your absolute max, and the smallest output is obviously your absolute min. Keep in mind the absolute max and min value is a y value, but you may be asked to find the coordinate, or another phrase for that would be the point, and in which case we would be answering as an ordered pair. Example 3, find the absolute max and min for a given function, and it catches my eye that I have a closed interval. This is a polynomial. It's a continuous function on a closed interval. So I absolutely will have an absolute max and min. First, I need to find the critical numbers. I wrote the word value here, but I've been abbreviated CM for critical number. The critical numbers are to find the derivative. So the derivative of 5 is 0. 54x is just 54, and minus x cubed is minus 6x. My derivative only has a numerator, so I'm setting my numerator equal to 0. Now in this case, I only have one variable, so I can isolate it by either subtracting 54 to the other side, although then I'll have a negative on each side. I could add 6x squared to the other side to get a positive 6x squared and a positive 54. I divided both sides by 6. And then if I were just to take the square root, I'd get 3. But because it's a degree 2 polynomial, I know I need 2 answers. This will always be positive, so we only get the principal root, which is positive. But 9, even though you may think of it as 3 squared, I see a 9. I don't see 3 squared. So we have to take plus or minus the square root of 9 to get our 2 critical numbers. But if you remember, step 2 said, make sure you're only using critical numbers that are in your interval. So I need to discard the negative 3. My closed interval was 0 to 4, and negative 3 is not in there, whereas positive 3 is. So my next step is to evaluate the critical number I kept of positive 3 and my endpoints of 0 and 4. I'm plugging in the critical number and endpoints into the original function. I'm not plugging them into the derivative. I usually like to start by writing the first and last endpoints and making sure this way that any critical number is in between them. So if I was tempted to write f of negative 3, I would kind of question, how did negative 3 come after 0? And that would be my reminder to get rid of it. I plug 0 in for x and get an output of 5. I plug 3 in for x to get an output of 113, and I repeat the same thing with the 4 to get positive 93. So the smallest of all of my outputs is positive 5, and the largest of all of my outputs is 13. So now I'm ready to answer. My absolute minimum occurred with an output of 5 when my input, my x value, was 0. My largest output of 113 occurred when my input was positive 3. Now, this will be the format I'm going to ask for on an exam, but sometimes homework, specifically WebAssign, may just say, what was the value of the absolute minimum? And you'd just be answering with the 5.